everybody who is watching this video. I'm very happy today to be with you in this fantastic moment. My name is Olenjolai TAYAI from the beautiful, fantastic, blessed, and even interesting country that's called the United Republic of Tanzania in eastern of African continent. Welcome everywhere where you are in the world. This is the time for learning the beauty of mathematics, especially in engineering and the scientific mathematics. Well, I would like to welcome you into our online school, which is called the Online Diploma Polyinstitute of Tanzania. So it's an online school, it's not a physical school, so we are teaching by using the online tools. Basically, currently, we'll be having a lot of things that we'll be teaching and even assisting or supplementing the diploma students. Currently, we are teaching the basic engineering and scientific mathematics, and we have begun to teach 6 modules, okay, which is the entire course for the ordinary diploma students. And the modules of the day is called trigonometric vector. In some of the curriculums, they call it trigonometric vector and complex number. If you review the general introductions, I've already cleared that the challenge of in different institutions to have different names of the of the modules, but the content is still the same. This is for the first year ordinary diploma in most institutions. Many institutions in Tanzania is taught in the second semester. The topic of the day is vector. And then this is session 4, which is called the internal and the external division of a vector. So I would like just to introduce to you a few things before we go to the session. Firstly, I thank God who have given me this idea of solving real life problems on teaching ministry. Thank God who gave me the gift of teaching. He's the one who gave me and who is with me right now when I'm teaching you this beauty of engineering and scientific mathematics. How can you get connected? In these official YouTube channels, we'll be adding hundreds of videos in total. So every day, or possibly that after 2 days or 3 days, it means we'll be always be adding new videos of different concepts and different topics, so that to train students worldwide. However, that we are training, we are doing our programs locally, means that locally, but we have a mind of international and of national and international. When I say national, we have a mindset to cover and to teach all the ordinary diploma students who are pursuing science and engineering courses in the United Republic of Tanzania. But again, this content may be used internationally. It may be used in Asia, may be used in China, may be used in, you see, it may be used in European continent, in North America, may be used in South America, may be used in African continents, in Australia. So these contents are well, because mathematics is a global or universal subject. So I would like just to tell you 4 things that you have to make sure that you go through or you do in order for you to stay connected, because you know that even in the physical schools we used to have something that we used to call the registrations, early registration, right? You get registered, maybe after a year, you come, you pay the tuition fee, and then you register. So this is a kind of just like how you can register into a program, okay? As I say, that the first thing, you have to make sure to press the button subscribe and subscribe in our YouTube channels, and you have to sign in by using our official channel. So once we upload any new video, the YouTube community will send the notifications once you are online. Secondly, we ask you to share these contents with all the ordinary diploma students in our country, or even in Africa, or in other countries, or in other continents. Number three, we like to we insist all the students, all the viewers, to read the description sections, which is you click the buttons that show more in each video, and then you'll see some of the descriptions which have been given for that particular video. But again, there we used to provide invitation for all viewers and even all students or teachers or mathematicians who have been happy with this program and they want to offer God the Thanksgiving offering, because currently we don't charge our students any amount of money. We are doing free. This is our Thanksgiving to God through the Tanzanians and also other diploma students worldwide. Okay, for a particular time, according to what God has instructed me. So you can send your free willing Thanksgiving offering through the bank transactions. You'll see the bank account is NNB and the bank number, and even the bank name, right? The account name. Also, you can use the mobile transaction, which is the wrote here Thanksgiving 0759753381, which is my number, and your Thanksgiving will be received with hands of thanks and to be used effectively. Lastly, part of instructions, I would like to remind you, and I'll be reminding you in every video, because possibly this is your first video. Make sure that you watch also session 00, which is the general introductions of ordinary diploma of basic engineering and scientific mathematics in Tanzanian curriculum. So make sure that you watch it before this one. So again, how will you ask the questions when I will be continuing on teaching? That's a good thing. I use the comment sections to do at least 5 to 6 things. You can do 6 things by using the comment sections, and I will see them. Number 1, you can use the comment sections to ask the questions. Number 2, you can use the comment sections to answer a question that other students have asked them. Number 3, you can use the comment sections also to give me the feedback, whether you understand or you didn't understand. You mean that to explain yourself, just like in a physical class, to say thank you, it's enough, right? If this content has helped you. Then number 4, you can use the comment sections also to ask you questions. You can use the comment section to ask out the questions. And then number 5, you can use the comment sections also to submit your homework. In every lecture, I'll be leaving the homework. So for you to try, even in today's lecture, I'll leave the homework. Make sure that you try it yourself and make sure that you submit. Don't worry that the homework will be public. Don't worry about that. Our main objective is just learning. Then, before we begin the programs, I'll always remind this the one. Olenjolai does not know everything about basic engineering and scientific mathematics for the ordinary diploma students. I just know a small portion, but I'm ready. I'm not jealous. I'm not selfish. I'm ready to share it, what I know, to those who need this concept, right? Again, one thing which I want to tell you that our main objective to do these programs is not just to help students to pass exams. Exams are just a subset of our program. Our main objective in this, and if you ask me that, why are you doing this huge business? Why are you training Tanzanians? Why are you training ordinary diploma in Africa, in America? That's a good question. And the answer is this one is already written in my heart by the Holy Spirit. Just he told me that I want to see the community of Tanzanians that can use the classroom instructions that they used to get in order to solve their real life problems, right? So that's the main objective. We want to see the community of Tanzanians, let me repeat, who use the classroom instructions and solve real life problems, not seeking for the employment, not those who are just seeking for the certificates. I'm not dealing with those. However, you will get certificates, you'll pass exams in this program. Those are the subset. Those are subset. When I say subset, I'm speaking mathematically a little bit. Subset is mean just a part. Okay? Those are the part. But the entire braid is solving the real life problems. And I will teach you how to think differently in this program. Right? So if that, I believe you are ready, and then you are, thank you very much, Justy, for listening in. Then let us go to today's business. I left the homework. I want to do the quick review of lecture 3 of vector. Then, but that times I taught you about the another terminology which you call what? Which terminology did we learn? I think there's one terminology that we finished, and then we came to some other concept. What the name of that terminology? What the name? Is it what? How do you call it? Yes, I remember. Yeah. Thank you, God. Angle of a vector. How can you find angle of a vector? This, I think, was terminology number 8. And then we say that the angle of the vector, this is formed by using this formula, tan inverse of y component over x components, so that the angle, or arctan y over x. Then I told you about triangle law, right? Triangle law, and as triangle law, we say that one vector which is completing the triangle will be, let's say, vector B plus vector C. So these are the two vectors that this remember, we have initial and final point, so you have to do the revision. Then I told you about parallelogram law, right? Parallelogram law, we say that if you have a parallelogram which is like this, okay, and then we have against, we prolong like this one, then we say that the resultant will be the what? will be the diagonal, right? While here the resultant will be the triangle. For example, this we can present like this. So this is the, I can say that this is the beginnings of the vector. So you have a vector that's going, and this is the end of the vector. So you have two vectors like this one. So suppose that this is A, and this is vector B, this is vector C. So the resultant vector, so for that case, let me just reverse. Okay, so this is vector A, this is vector C, in order to be synonymous with the equation that we have. And this is vector T, excuse me, this is vector A, and this is vector B, right? And hence, I talked to you about what? Polygon, say polygon rule, right? Polygon law. And polygon law, we say that can have several vectors, right? Several vectors are joined together, the first vector, the third one, the fourth one, and then this is the endpoint. So we can say that we can take only one closing line. So we say that, if you remember that if this is A, vector B, vector C, vector D, and this is vector E, so according to the polygon law, vector E is equal to vector A plus vector B plus vector C plus vector T, vector D. So in case that you want to get too much details, and hence we ended the sessions with basic operations of vector, which are addition and subtractions. So in case you want to get too much details, this lecture is still in the YouTube channel, so you have to make sure that you go through it. So today, we like to begin the business with fantastic and exceptional concepts. And the first thing I want to teach you properties of additions, right? Properties, say properties of addition of vectors. Additions of vectors. So we say that suppose you have vector A plus vector B, this is the first property. Then we say that according to the vector rules of vector, this is equal to vector B plus vector A. You know how do you call this property in set? This property we call it, or in Boolean algebra, cumulative property. It's just like in normal numbers. If you have 4 plus 3, this is equal to 3 plus 4, and the meaning of cumulative property of vector. Then the second property, we say that if you have vector A and then plus opposite directions of vector A, then the answer is 0. What does it mean? For example, if vector A is in this direction, right? This is vector A. So negative vector A will be in opposite direction. Interesting. Mathematics is beautiful. Then the second rule is we say that in case you have 3 vectors, and this is associative property. Vector A, if you have vector A plus vector B plus vector C, right? According to the laws of vector, this is equal to vector A plus vector B, and then we change the positions of bracket, then plus vector C. This in mathematics we call it associative property of associative property of vector. Associative. So we change the position of bracket. Here brackets was enclosing vector B and C. Here brackets enclosing vector A and B. That's what we call it associative property. So we have some other more properties, but these are enough, just like a fundamental concept for you. So now let me take you into another concept before I bring you into the ratio theorems and the internal and the external divisions of a vector. Another concept which I want to teach you in advance is called the scalar multiplication. Scalar multiplication of a vector, right? Of a vector for ordinary diploma, right? Scalar multiplications of vector. What is the meaning of scalar multiplication? It's a product of the real number and the vector. So simply scalar multiplication, right? Scalar multiplications. Ask that question to yourself. Scalar multiplication is the product. Product of what? It's a product of real number. Let me write in capital letters, just to show you that this is the keyword. Real number, right? And what? And a vector. Or a product, this is in addition, a product of what? Of scalar quantity, because you find this one in vector equation of the line in the equation of the vector. A scalar quantity. Scalar quantity, for example, lambda is the common scalar quantity. The other one, I don't remember the other ones, I remember just, so you can fill the blank. Look for the other ones, okay? Scalar quantity, and what? And the vector. And vector. So these are the definitions of the word scalar multiplications. You may not ask in exams at what is scalar multiplications, but remember, in these programs, our main focus is not to answer exams. Our main objective is solve problems. So in order for us to solve real life problems, we have to understand what we are learning. So we can take it from the inside the class and solve the real life problems and save the life of our community. Say amen if you're here. Okay, so that is the scalar multiplications. How we write scalar multiplications in mathematics, right? So for example, if we begin with the first definition, that is scalar multiplication product of 40, a real number and a vector, it means that these are the examples of 40, examples of scalar multiplication, SM. So if you write 3 times vector A, that's the scalar multiplications. If you write, let's say, 4 times vector B, this is scalar multiplication between a real number 4, this is the real number, and this is vector B, vector A. If we write again, let's say that we have a half times vector C, this is scalar multiplications. So these are the examples according to the first definition, that the product between the real number and what product. Again, I told you that it's a product of 40. Scalar multiplication is the product of the scalar quantity, so scalar quantity. Scalar quantity out in the vector. How do we write? For example, scalar quantity of vector A with the scalar quantity A, or which is lambda, is written like that one. Or lambda times 40 times B, or times vector B. Or for instance, that we say that here we have also lambda times vector C. We can also have maybe twice lambda vector A, but that is a little bit complex for your level. So, etc., 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 etc. So I believe you have understood the definitions of 40 of scalar quantity. So we'll see it, how does it work. So I have example. This will be example 7, simple example. Okay. So we say that given vector A is equal to 3, 4. Let me write it in vector form. 3i minus 4j, right? And then, plus A. And then say vector B is equal to what? I plus 3j minus 4k. So the question asks you that find what? The scalar multiplication of 3 times vector A. B, find scalar multiplications of 4 vector A plus 8 vector B. C, so this is your homework. Or I will do this for you. You can find that the scalar multiplications of 10 to vector B minus scalar multiplication of 3 is vector A. So this is your homework. After that, I'll teach you about some of the rules or laws. So solution, I'll solve Roman A and B. Roman C is your homework, and you have to make sure that you submit your homework in the comment section of this video. Please submit the homework in the particular video which you have been given as that homework. So solution, we say that the first step we have to deal with scalar multiplication. So we are looking for 3a, right? So simply the first step we go straight forward, compute what? 3 times vector a. So 3 times vector a, this is equal to 3 times components of vector a. What are the components of vector a? It's 3i, right? 3i, and then minus what? Minus 4j, right? Plus what? Plus k, right? So then we say that 3a, this is equal to 3 times 3. So this is scalar quantities multiplied to each vector component, right? I think that I have to write it here. Now suppose that scalar component of vector a, this is equal to scalar times x1a, maybe ji, lambs, what is scalar times, let's say y1j at the minute. So 3 times 3, I, it is 9i, minus what 3 times 4, it's what 12j, then 3 times k, it is what is 3k. So this is the final response. Then we go for part B. So part B, the questions ask us to do an additions of scalar multiplications of the two vectors. The first scalar multiplications is for a plus what? 8b. Right? 8b. So how do we solve this one? We take a and multiply with components of vector a, which is 3i minus 4j plus k. And then we say that plus what? Plus 8 times components of vector b, which is i plus 3j, I plus 3j minus 4k. So then simply it's just multiplications. You open the bracket, multiply each scalar quantity with respective component. 4 times 3 is 12i. 4 times times what? Times 4 it is 16j. 4 times k it is 4k. Okay, this is the result of the first scalar multiplication. 8 times I, it is what? 8i. 8 times 3, it's what? 24j. And hence 8 times this one is 32. Okay. Next, you combine the like component. So you combine the components for I and I, j and j, k and k, and you do the best comparison with additions or subtraction. So 12i plus 8i is equal to 20i. The negative 16j plus 24. So it's equal to what? Is equal to 8j. Right? And then we have 4k minus 32k. So it's equal to what? Negative 28k. So this is the final response. Simple. So if this is the final response, then now you can do the what? You can do the homework. There are some few rules of scalar multiplications. Say the rules or properties of scalar multiplications, because sometimes you can find in some of the problems they ask you is this. They test you understand the properties of what? Of scalar multiplication. What are the properties of scalar multiplication? So you have some of them. The first property we say that and this we are dealing with a scalar quantity now, not real number. We say that let suppose that vector A or A and B are vectors. Positional vector or displacement vector are vectors. And then this one and T are any scalar quantity. Right? So now we can use them to learn rules or properties of what? Of scalar quantity. We start with what? Lambda. In case that we have lambda, we have vector A plus vector B. We did this one. So this is equal to lambda times vector A plus lambda times what? Vector B. We didn't do this. We found that we have been already given, right? Then for T, similarly, same concept. Again, that's the first property. The second property is in case also we have a vector now multiplied by the sum of the scalar quantity. What happens here? Right? So according to the rules, you open the bracket. If you open the bracket, you take scalar. It means that you take vector A for that case times scalar lambda, then you take vector A times scalar quantity T. But this is not a final response. Why? Because we always start writing the coefficient before the variable. So here the coefficient is scalar quantity, while the variable is what? Is a vector. So we have to rewrite it in this way. Lambda times vector A is just like we cannot write x3. We just write as 3x. That's what I mean. And then here we have 3, what? Lambda A, and then we have what? T times vector what? A. Okay, that there, second property. Then we have a third property. What if we have a product of the two scalar quantity? Lambda times T, and then multiplies vector A, or is vector B. So let me write it downstairs because we have that ones. Means let's say that here we have what? Lambda plus what? T is equal to that. Then we have the third property. Third property, we say that suppose you have products between the two scalar quantity lambda and T times what? Vector A. What will happen here? So the response will be the product. Yes, we can just take one of them out of the bracket, that's all. For example, you can take lambda out, and then it remains scalar times quantity. This is the way that we write. Right? And then in case of magnitude, I taught you also about the property or the issue of magnitude. If you have magnitude of scalar times vector A, what will be the answer? So the answer, this will be equal to the magnitude of the scalar quantity, which is equal to the scalar quantity multiplied by magnitude of vector what? Magnitude of vector A. These are useful properties, right? But the magnitude of the scalar is what? The scalar, as I told you, because if you square scalar and then you find to square root, you get a scalar. So this is the final response, right? Okay, you enjoy the beauty of engineering, and you enjoy the beauty of basic engineering and scientific mathematics for ordinary diploma students? Yes, I believe you too. Okay, so then that's all about these primary issues. Now let me take into the desired business. I want to take you into the internal external division of vector. It's a little bit challenging concept, and now we are start getting into the challenging parts of vector. So let me teach you about ratio theorem before I teach you about internal division and external division of a vector. Say ratio theorem. Ratio theorem. What the means of ratio theorem? Or how can you state the ratio theorem? So say the ratio theorem is a theorem that representing a ratio of lines or vectors, parties, or proportions. So you say that simply we say the theorem that presents what? Ratios of line segment or sublines, is ratios of what? Because ratios of parts of, say that parts of lines, coordinate geometry, or present ratios of what? Of vectors. It means that ratios of parts of vectors. This is according to my understanding, parts of vectors. So let us deduce ratio theorem of a vector. That's the reduced ratio theorem of what? A vector. So we'll be following some few steps. The first step, we say that consider possible displacement vector. We know what means a displacement vector, right? Displacement vector PQ, right? PQ shown below. Okay? So suppose that we have a certain vector, which is this. This is initial, maybe P, see final Q. Right? And then afterwards, so this is, remember vector should have direction. Suppose that we want to divide this vector at that point, and let's call it 20R. Right? So we want to cut that vector at that point. We want to shorten this. Okay? Okay, fine. And then when we divide, suppose that the magnitude from here to here, it is M. And the magnitude from here to here, it is N. Right? So then mathematicians have stated the theorem there and the relationship between those quantities, and we need such kind of the relationship on learning internal and external divisions of the line. Right? So remember that in case of ratio theorems that we say, for example, that if you have ratio theorems of, let's say M ratio, so this is the way that you write, ratio M. So that's the example. Okay. So if that's the case, you say that we can have a certain vector. So suppose that PQ, yes, suppose that vector PQ, this vector PQ is equal to vector A. But we can let it. Okay. So second step. Second step, we say that we can find so second step, we say that, or before even you say that, suppose that 20R divides what? Divides vector R, or divide vector PQ in ratio of M and N. Right? So we say that according to the ratio theorem, we say that this part of the vector, which is vector PQ, will be equal to the value of this ratio between these 2 points divided by the sum of the ratios multiplied by vector PQ. What does it mean? So ratio theorem say that if I want to know the part of PR, which is the part of the vector PR, then this is equal to what? Is equal to ratio at that particular point of the vector P and R, which is M, divided by what? Sum of the ratios, like this one, multiplied by what? By a vector PQ. So as you say there, in case that you want to get vector PQ as is equal to vector A, so the ratio theorem for the line segment, or for the part of the vector, right, PR, this will be given as ratio M over sum of the ratios, and then we multiply it with vector A. Very important in ratio theorem for your life. Okay. Again, we have another formula of ratio theorem, which is the second part of the vector PQ or vector A. Second part is RQ, right? So the vector RQ, right, this will obtain by taking its corresponding ratio, which is N, over sum of the ratio, like this one, multiplied by vector PQ. But we let that the vector PQ, it is what? Vector PQ is equal to vector A. So we say that RQ, this is equal to what? N, M plus N, and then multiplied by vector A. This is very important ratio shown. Okay? I think that right now that something is going on in your mind that, hey, this is stuff now, a little bit complex. So we need them in learning the internal and external divisions of what? Of a vector. So if that's the case, you have understood. In case you have any question, don't hesitate yourself to ask in the comment sections. You know, I learned this business 10 years ago, so it is normal for me. Right. Now I want to take you into the next part of this lecture, which we call internal division. Internal division of a vector. Say internal division of a vector. So he said that a vector can be divided. A vector can be divided. A vector can be divided A vector can be divided internally or externally. So a vector can be divided internally or externally. So you say that a vector can be divided internally. Okay, a vector can be divided internally into ratio m dot n. M and n. So suppose that. Or in ratio, or by using ratio for m. So say that internally by using ratio of what? M and n. So let us use the triangle law. We have deduced the general formula. Remember that we taught you the concepts of internal and external divisions. Also, we used to teach you in coordinate geometry, but there is internal and external divisions of what? A line in geometry. So we want to derive the formula. I want to teach you how to derive. In case you be asked me, you can derive the formula of what? Of internal division. Internal division of a vector. Internal division of a vector. So we'll be using the triangle law, and then we'll be using the geometrical representation. Right? So I'll be teaching you how to write by following steps. So the first step, we say that consider, okay, the geometrical representation of vectors below. Okay? So vectors below. So you have the xy plane. Suppose that you have xy plane. This is the xy plane. Okay. Then this is region like this. Okay. So I want to see the shape at least that, you know, having a good shape is important. Let us draw this geometrical representation. We say that suppose we have stand line like this. Okay. Then we have another line here. This is our vector AB, and we have another vector here. This is the vector now which is dividing another vector. These are the, here we have positional vector and displacement vector, right? We have positional vector and displacement vector. So this is O, this is point A, right? Suppose that this is point B. This is y-axis, as usual. This is x-axis, as usual. And then we say that this is the vector A, in terms of vector. Suppose that this is vector B. And then suppose that here we have another point we go to C. So OC is the vector that dividing vector AB. AB also is the vector we call displacement vector, but this displacement vector is a joining of the two positional vectors. Our interest, we want to know the vector that dividing internally, vector A and vector B. So what we do, so for example, for instance, it means we can draw vector A itself and vector B itself, and then we want to divide them internally. So it means that we have a certain vector here. And then this vector that dividing vector A and B, we call it vector C. Right? So also, so the final points of these vectors is point B. So now already we have triangles. How many triangles do we have? We have 3 triangles. Triangle OAB, we have triangle OCB, we have triangle OAC. Testing. Had the beauty of what? The beauty of vector. So if the triangle, then we can use the triangle law. So the second stage, say that use triangle law, right, to deduce resultant vector, right, of each triangle. So look careful. I said you have how many triangles? 3 triangles. So let us start with the large triangle. So let us start with triangle OAB. We apply what? We have OAB. We apply what? Triangle law. So initial of the vectors, which origin, final point. So there we say that it will be our resultant vector. So what will be the resultant vector for this case? Is vector B. So our resultant vector B, this is equal to vector A, right? Plus what? Vector AB, which is displacement vector. So this is the first equation. It's very simple to derive the general formula of 40 internal divisions of a line. It's similarly like in coordinate geometry. So you have to enjoy. Then we go for the triangle. The next triangle we can choose. Let me choose a triangle OAC. Triangle OAC. What the resultant vector? Initial point. Suppose that is the final point. So our resultant vector is C, right? And what? And other as a side vectors is vector A and the vector AC. So you say our resultant vector is vector C. You see the importance of lecture 3, vector C, and then this vector C is equal to vector A plus vector AC, which is displacement vector Suppose that this is the second equation. Then we got the last triangle, which is triangle OCB. Triangle OCB. So here also we have direction of a vector. Initial, final. Then tell me, okay, what the resultant vector there is, vector B, right? So it means that the resultant vector is vector B, which is equal to what? Is equal to vector C, and then what? Vector C plus what? Displacement vector, which is CB. So this is the third equation. Okay, so remember that resultant vector C is the vector that dividing position of vector A and B in ratio of M and N. So now allow me to add what? To add ratio values. Suppose that A to C, this is M, and then C to B, this is M. Right? So we have our triangles, not in a relationship, because not in a relationship, not in a close relationship. Yes, no, maybe you can substitute C to C there, you can eliminate, but we can eliminate B, then you say that this is equal to that, but it will be just moving around. So we go for the steady state of our derivation. Say steady state. So the steady state now, we have to recall what? We have to recall the formula of 40 ratio 7. So what the formula of ratio 7 for instance for that case? These are the two formulas. We say that displacement vector AC, this one, right, will be equal to what? Remember, M over sum of the ratios, and then we multiply by what? By the whole vector, which is vector AB. So this will be the first equation. Right? Again, we can